Hello everyone. Welcome to this session on QGIS plugins as part of the online training program on Introduction to Remote Sensing and GIS using QGIS. Till now we have seen the basics of GIS, remote sensing, and then installation of QGIS on our systems and working with text data, delimited text data, vector data, raster data in QGIS, preparation of basic maps, georeferencing, digitization, and also how to do basic spatial analysis. We had also used Saga tools and GRASS tools for delineation of river basin in QGIS. We have seen both the methodologies, and now in this session we will see few important or popular plugins. In the very beginning, at the very initiation, we said that QGIS has this plugin architecture which allows users and developers to increase its functionality. Plugins are like add-on tools that extend the core functionality of QGIS, enabling us users to perform specialized tasks beyond the default capabilities. We have started using many of the plugins like Quick Map Services, Quick OSM. Then we had also used some tools like Data Coordinate Capture, Value Tool, etc. We will be revisiting some of them, and we will be seeing some new plugins in this session. Let us quickly summarize the QGIS plugin architecture one more time. The plugin system of QGIS is one of the most valuable features of QGIS, and which enables extension of its basic capabilities. A plugin is nothing but a small piece of software or code uh, that extends the functionality addressing a larger application, making use of the existing QGIS tools in the processing toolbox. If you see, there are hundreds of tools for basic purposes, basic vector tools, basic raster tools, and other tools. And if you create a workflow making use of these tools to address some problem of from your domain area, and then you can create a plugin by writing a code linking up these tools, or you can write your own code for alternate code for these tools. And then once you prepare a plugin or develop a plugin, and there is a set procedure for uploading it and getting approved for inclusion in the QGIS plugin repository, official plugin repository. Once it is approved and uploaded in the QGIS plugin official plugin repository, it will be available for download for all users. Apart from the official repository, there are other repositories where you can also find plugin, but they will not be readily visible, so users may not be able to see them easily. So yeah, so what it does, what is the basic use of plugins? The plugins add new tools, or automate the workflows making use of existing tools, and they enhance the user experience, who need not think much about what are the tools that you can make use of from the available list of QGIS tools and algorithms. Addressing and if they want to address some specific problem of their domain area, then they can make use of such plugins. Then plugins are usually developed or created by users and developers, because it is the whole QGIS is an free and open source software which enables users to contribute. And there are some organizations which have developed plugins. You will find such plugins, popular plugins, and some of the plugins, they come pre-installed, which are core plugins that they come along with installation of QGIS, like processing toolbox. Its processing framework that itself is a core plugin which without which you cannot think of QGIS. It comes along with QGIS and you cannot uninstall it. And but majority of the plugins are developed by they are like third party from third party users or developers, and they are available via the plugin repositories. There is one official QGIS plugin repository, and there are other repositories. The plugins can be enabled or disabled via you have seen how to enable or disable plugin once you install them. Now, what is the disadvantage of installing lot many plugins is your QGIS when you start the QGIS, it will take lot of time to load. That is because it gathers all the data pertaining to the plugins. In such cases, what you can do is, if you are not using the plugins regularly, you can uncheck them or disable them. You can go to this website of plugins.qgis.org. Let us see. So this is the web portal of QGIS plugins official repository, and you can see that plugins are developed by independent organizations and developers, and QGIS organization doesn't take any responsibility, and you can report any bugs or feature requests that you can report. Yeah, and if you want to author your own plugin, there is one good resource, QGIS PyQGIS Cookbook, which contains a section on developing plugins. You can have a look at it. I think it is a book which is available. Yeah, no, it is open access book. So you can go through this in case if you are interested in developing a plugin. And then there are other references like QGIS Python API, QGIS C++ API. Most of the plugins are either written in Python or C++. Then there are some references on how to publish your plugin, how to get your plugin approved, and there is a frequently asked questions section which you can explore. These are some of the if you want to look at some of the popular plugins, you can go to this section, popular plugins. Yeah, some of the popular plugins, most downloaded plugins, most voted, and best rated plugins. And some of the plugins are in experimental stage that if you want to even try out experimental plugins, you need to make a slight change in your QGIS settings. Otherwise, experimental plugins will not be visible. So if you see the popular plugins, we have used this quick map services by a company NextGIS. And if you want to look at all the plugins which were developed by NextGIS, you can also see them. So this is basically to add base maps. And then quick OSM also we have used for downloading OSM data using Overpass API. Semi-automatic classification plugin is one plugin which allows for supervised classification of remote sensing images for preparation of LULC map, which we will be making use of in the coming session on LULC mapping using QGIS. Then HCM GIS, it also provides base maps, and apart from base maps, it also provides download options, batch processing options, field calculation option utility. HCM GIS, it is also a popular tool. Then Latlon tools, this is used for capturing coordinates and zooming to the coordinates. Then MMQGIS, it is a collection of QGIS vector layer operation plugins. Profile tool, it plots the terrain profile. Now in the raster analysis session, we generated contour map. Now if you have a DEM, so if you can make use of profile tool to draw a line, and then you can get the section of terrain, how the elevation varies along the line, that it will a plot can be generated. Then QGIS to web, export to an open layers leaflet web map for creating a web map. Then QGIS to three-dimensional 3JS, that is 3D map visualization. So there are so many plugins. Google Earth Engine. If you want to integrate QGIS with Google Earth Engine, in case if you use Google Earth Engine, you have an account. There are some functionalities that you can directly use in QGIS by linking your by authenticating and linking your Google Earth Engine account. Street View. And there are some plugins on digitization other there. So you can see this is page 1 of 133 pages. There are hundreds of plugins. These are the most popular ones. Similarly, you can click on most downloaded. You will find the same set of plugins. Maybe you will find some new, like this, some tools, KML tools, even most voted, processing Saga next gen provider, which we have used for making use of Saga tools, a processing provider for modern Saga releases, and best rated plugins. So these are some of the best rated plugins. Most of them are new, so you can explore. Even the new and updated under this news and updated. Now QGIS 4 is going to be launched soon. So some of the plugins are already QGIS 4 ready. So you can get a list of those plugins, and recently released plugins you will find them under new plugins, list of plugins that have been created in the previous month. So you can have a look. Then the plugins which have been updated, they get regularly updated as the QGIS versions keep on improving. Or you want to the developers themselves want to improve their plugin. So recently updated plugins, you can find the list of them. So that is about plugins, and you also have the documentation here, how to publish a plugin, how to get it approved, etc. So if you are very good at coding, or if you have a problem statement, and if you want to create a plugin, you can follow these guides. You can follow the QGIS cookbook to create your own plugin and then get it approved. So let us have a look at some of the useful plugins which are available. Launch your QGIS and open a new project from the main menu, and go to this plugins in the section in the main menu. We have already seen this manage and install plugins. So you can see it is fetching repositories from the official QGIS plugin repository. Now if you want to even have a look at other repositories, you should know the URL, and then you can go to the settings page, and here you see only the repository that is there is which is connected is QGIS official plugin repository, and you can add any other repository. You can configure if you know the name of the repository and then the URL of the repository, then you can enable it, and here you will get the other repositories which are having other plugins. Now if you also want to have a look and make use of experimental plugins, you can check this box. So it warns that experimental plugins are generally unsuitable for production use. These are in early stages of development and should be considered incomplete or proof of concept tools. QGIS doesn't recommend installing these, but still uh, if you want to see the listing of even experimental plugins, in case if you have come across information about some experimental plugin which is very good, then you can check this box, and then you can find the experimental plugin in the search results, and you can start making use of such plugins also. So you can check this, and there are some deprecated plugins which are again, they are not suitable for production use. They are those are like the users and the developers are no longer maintaining them. So they are like obsolete tools. Some of them may not work with the newer versions of QGIS, but if you want to have a look at those listings, then you can check this box also. So in this way you can change the settings. Now I have checked this experimental plugins also, because we may try to see one or two experimental plugins, and the plugin listing will be there in this tab all, where you will find there are about 2227 plugins which are available for QGIS. Some of them are already installed, like coordinate capture, then GRASS GIS processing provider. It is again a core plugin. It comes along with QGIS. Earlier, even Saga processing provider used to come as a core plugin. Um, so it is already there. And then again processing. This is again a core plugin. You cannot uninstall it. Quick map services that we had installed. Processing Saga next generation provided that we had installed it. Now there are if for enabling any plugin, you can check the box. If you don't want your QGIS to be slow, or not at the time of launching QGIS, if it is taking lot of time, you can disable those plugins which you are not readily making use of. There is also another way of installing a plugin. If you are provided with the zip file containing the plugin to install. Such files you will find in the pages like GitHub pages of some of the plugins. You can install by uploading this zip file and then installing the plugin. But it is not the preferable way of installing plugins. The preferable way is to install directly from the repository. We have already installed the most popular plugin and most downloaded plugin, which is Quick Map Services, which is used for adding base maps. Easy to add base maps. The provider is NextGIS. You can launch it from the web main menu under Quick Map, and there will be a section of Quick Map Services once you install the plugin, which you had seen. But if you are installing for the first time, there is one thing that you need to do to get all these options of base maps. You have to go to Settings and then click on More Services tab and click on Get Contributed Pack, so that the last version of contributed pack will be downloaded, and then save it, and then you will find all these options of various base maps. You can explore all of them. You can also access Quick Map Services from this toolbar. A toolbar of web toolbar will be there, which you can if it is not active, you can right click or go to view and check the toolbar of web toolbar, and you will find this icon of globe, which can be used for accessing the Quick Map Services. Another popular plugin which we had already made use of is Quick OSM. Quick OSM is for downloading OSM data using Overpass API. OSM, OpenStreetMap data, as we had seen in a session on open access datasets, is a crowdsourced data, especially when you are looking for local level data of buildings and highways, roads, and amenities such as schools, restaurants, and other public amenities. It will be a very useful data set. So you can launch once you install it, you will find it under Vector Main tab. A section of Quick OSM will be created, and you will also find the icon in the toolbar. You can launch from there. And how to fetch data? You have to go to this tab of Quick Query, and you can look for the wiki page of OpenStreetMap for the data, how it is stored as a key value pairs. You need to get the value of key and the name of the key and the value, corresponding value, and you can type it here. For example, you can say waterway and then say canal, and you can fetch the data for a layer extent if you have added a layer in the map canvas, the layer panel, or you can get it for a canvas extent by zooming to the location. Say let me add a base map of OSM standard, and then I can search for any location using this status bar, which we had already seen how to make use of it. You can go to check this nominatum geocoder, double click it, you will get this arrow mark, and then there you can type Pune. Say you want to get it for the extent of Pune district, that is a larger area, a bounding box containing Pune district as well as the adjoining areas, right? So now you can check this canvas extent and go to advanced, and the type of the feature will be line and multi-line string. You can increase timeout. Suppose if you are fetching the buildings data for a larger area, many a times what happens is it will fail because of the timeout. You can increase this timeout in such cases if you are unable to fetch data, and then you can run query. Now canal data will not be much. It need not have the whole all data because it is crowdsourced data. If you want actually the data of say dams or canals or water resources projects, you should get from authenticated sources. This data will be more useful for creating local data, for if you want to fetch a local data or you want to create your own vector data set for a particular region, small region, for conducting spatial analysis. That something which we have done. So now it is done. It is the query is successfully run and one layer has been loaded. You can check the layer. Let me yeah. So if you can uncheck this OSM standard, this is the canal data from the OpenStreetMap. You can check the Kadakwasla Dam. Yeah, this is the Kadakwasla Dam. So there is a Mota right bank canal which is coming going from the dam all the way through the city of Pune and downstream of the city. You can select the feature like you do, like you can this will be a temporary layer. You can save it. If you want to select the feature, you can make use of this, select, switch off your base map. Yeah, so this canal section is saved in segments. This is second segment, this is third segment. If you want to get information, you can click this identify features and click here. So you will get all the information. It is Muta right bank canal. So you can see it is similarly there are many canals from many water resources projects are there. You can find many of the data sets. So so that is about quick OSM. Another plugin that we made use of during this training program is group stats, which we used in the session on working with delimited text data. This group stats plugin is a handy tool for summarizing and aggregating vector attribute data. Just like you use pivot table in Microsoft Excel, you can quickly compute statistics grouped by one or more fields, the column headers, in any vector attribute table. Value tool is another plugin which we made use of. It is a very simple tool which allows you to view the raster, the values corresponding to your mouse pointer for all the raster layers which are there in the display. Now you know these identify features can be used for getting the attribute data of any feature in a vector layer displayed in the map canvas area. Similarly, it can give you the pixel value if your raster layer is displayed in the map canvas area. Suppose if you have a stack of layers which are added to your layers panel and they are displayed in the map canvas area, to get the value corresponding, all the values corresponding to your mouse pointer, you can make use of this value tool. And once you download it, you will find this icon which will be there in the value tool. In the plugins toolbar it is there. So you can launch it and then here I have just added the single tile of DEM which we used for delineation and and the merged DEM tile. And if I take my mouse to the location, you will find the values on the left side bottom in the below, just below the layers panel. You have a value tool panel where you will interactively you can find, as you move the mouse, the value will be displayed. And this is just a simple example. Suppose if you want to know the pixel values corresponding to different layers, say rainfall, say soil moisture, or any other parameter, then you can make use of this value tool. Another simple plugin that we made use of was coordinate capture, for capturing the coordinates of your outlet before delineation of the basin. You can check for coordinate capture. Yes, it is already installed. It captures the mouse coordinates in different CRS. Basically, if you want to get the coordinates in your UTM projection as well as the original layer, that is GCS projection, you can get the coordinates by launching the tool from the vector main menu. You will find the coordinate capture, and then if you click on start capture and click anywhere in the layer, you will be getting the coordinates. Here both my CRS and the layer CRS, project CRS and the layer CRS are same. Therefore, you are getting the longitude and latitude. In case if you have reprojected it to UTM zone, then you will be getting eastings and northings as well as the longitude and latitude. This will be very useful for getting the exact coordinates on the stream when you zoom, because when you want to delineate your basin, you have to necessarily get the coordinate of your outlet on the stream channel that has been generated from the using the DEM. So you have to zoom to the largest extent and then you click on the stream to get the coordinates, and then you make use of those coordinates for generation of upslope area in case of Saga tools, or even in case of making use of grass tools, you need to provide the coordinates. In grass tools there is an automatic option, but coordinate capture is useful in case of Saga tools for delineation. Now let us have a look at few more plugins, useful plugins. The first one is Data Plotly, which is a plugin used for visualization, data visualization within QGIS interface. If you want to generate interactive plots and charts, you can make use of this plugin. You can install the plugin by going to plugins in the main menu, manage and install plugins, and search for Data Plotly, and then you can install the plugin. It is already installed here. So it is basically used for drawing the D3 plots in QGIS. Now what is this D3 plots? D3 plots is a library in JavaScript which is used for preparation of a variety of plots for data visualization. Basically they are interactive plots and charts that you can create. Now if you want to create those plots within QGIS, then you can make use of this Data Plotly. And this particular plugin is also covered in QGIS training manual. In the first session we referred to QGIS documentation and we talked about QGIS training manual, which comes along with the sample data. In the module 9 of this QGIS training manual, the plugins are covered. The quick map services and quick OSM plugins are covered, and also Data Plotly plugin is covered. So we will be demonstrating the same thing here, making use of the same data sample points. So let me first add my sample points. After downloading and after installing Data Plotly, you will find this icon of Data Plotly under in the plugins toolbar. You can add your sample points for going to vector. Now the training data is available in the training manual. You have to download the training data in the name QGIS training data master zip file. You extract, and then inside exercise data there is one folder of plugins. and there is one sample points dot the shape file. You can add it. It is simple random points wherein some parameter values are there. You can check the attribute table by opening the attribute table. So ID of the sampling point group, and then pH value, Cl value, chlorine, and Mg, magnesium. Yeah, so to make use of to generate a scatter plot between say Cl and Mg, you can launch the data plotly here, and then you can select the type of plot. These are the variety of plots that you can generate. So between two parameters, appropriate one is scatter plot, and then you can check if the yeah you can choose which parameter you want to choose as X field and Y field. This again, these panels are flexible, and you can drag them. You can check X field as Cl and Y field as Mg, and then you can give the marker color, which marker that you want. If you want to have points, or if you want to have say stars, and this is the color, and stroke color also you can choose. Say you choose the stroke color, and then you can click on this create plot option. So you will get this scatter plot. You can this is interactive in the sense, one thing is you can zoom in to any portion, and another thing is if you select any point here, the corresponding point in the map canvas will be selected. Like if you can even do the box select. I can select these particular points. You will see all these points are selected in the map canvas area. And once you finalize your plot, there are many other options of zoom in, zoom out, and then auto scale. Once you finalize, you can explore all these things. Now you can even change the style from here. Layout options, you can change it from here. These are the different tabs, and here you will find the actual plot. You can export it as HTML or export it as an image. So you can download it as a PNG file once you finalize your plot. So you can explore this in the training manual, make use of the sample points, and then here they have actually created two plots side by side. That is also possible. You can because sometimes it is more useful to have two plots with different variables on the same page. So you can create two panels and then create plots. This is scatter plot and this is box plot. So you can try this with the sample data. One more useful plugin is profile tool, which is used for creation of elevation profiles along any line, a raster value profile. It shows how the terrain height changes along any line. So you can install the plugin by going to plugins and then click on manage and install plugins, and then you can search for profile tool. This plots terrain profile. You can install it. Once you install the plugin, a new icon of terrain profile will be created in the plugins toolbar. Now to demonstrate this, I will be adding one SRTM layer, the same layer which we have used it for delineation of Khadakwasla catchment. So I have browsed the raster layer, and then I am adding to my map canvas area. Now this is a if you see, this is the western divide. As you can, my mouse is tracing the divide, which divides the west flowing rivers from east flowing rivers. You can zoom to some location, and then you launch your profile tool and place your mouse cursor somewhere here. Like you can start by clicking the left button, and then across the water divide, say here. I can you press your left cursor again and press your right cursor of the mouse to stop the creation of the line. Now then you go to this profile tool and click on add layer. Then it will generate this elevation profile along the line. As you can see, if you move your mouse, it is also tracing the line in the map canvas area, and then the profile the elevation profile is being shown. Now you can see from on the western side of the divide, it is mostly less than 100 meters or around 100 meters elevation. This is the plain area, and then you have this western guards where the elevation is over 800. In this portion, there are some locations where you will even go up, it will go up to the height. There will be a steep fall of around more than 1000 meters. Yeah, and you can see the x-axis, y-axis, you have the elevation in meters, and x-axis actually it is the EPSG, it is GCS, so you have degrees. You can, if you change it to UTM and then redo this thing, you will get the in meters. You will be getting the coordinates in the on the x-axis. You can download this profile as a PNG, as an image, and you will also find the maximum and minimum values of elevation along this line, 988 and 4.77. Let us draw another line and check. Yeah, this is the portion where you will find where the elevation is maximum. So yeah, left click and then right click. So the maximum value, as you can see, is maximum elevation 1457, and minimum there is some abnormal sink, or what you say, it may not be the actual, it may be an error, acquisition error. So but if you see here, you will find most of the points here in the other side of the divide, they are less than 100 meters or around 100 meters, and then there is a steep rise up to 900, and then there are different ranges, and you have the maximum height of 1300 or so. As you are traversing this location of bright portion in the DEM, it is of elevation 1300 plus. So in this way you can you make use of profile tool, and you can download this as a image, and you will also find the table. You can copy to the clipboard, and then you can along with the coordinates, and then in Excel, if you paste and do the transpose, you get a table for further. If you want to further make use of the table, you can do that. Then there are few plugins like Open Topography DEM Downloader and SRTM Downloader. There may be few more plugins, but these are more popular. So for directly downloading, in this case, digital elevation model data within QGIS, instead of going to the portal like USGS Earth Explorer or other portals and download the tiles and then you upload them in QGIS, you can directly access the digital elevation model. You can, for that you need to make an account in this website, Open Topography, opentopography.org. You can create your account, and it has many of the digital elevation, open access digital elevation models are available at one place from where you can download. So you can access the open topography data directly in QGIS using a plugin, Open Topography DEM Downloader. You can install the plugin. This plugin will download DEMs from opentopography.org for user selected extent only. For that you need an API key. You have to get an API key from opentopography.org to download the DEM, for which you need to you have to register and create a login. You have to create, you need to have your login credentials to this portal, opentopography.org. Now these are all the different DEMs which are available. SRTM 90 meter, 30 meter, ALOS 30 meter, then Copernicus Global DSM, NASA DEM. There are other open access bathymetry data are also available. These are derived data sets. So let us see how we can make use of it. Now once you install Open Topography DM downloader, an icon will be created in plugins toolbar. You can launch the DM downloader, Open Topography DM downloader, and you can select the DM that you want to download. Say you want Copernicus Global DSM 30 meter. There is some description about how to get the API key, what is an API key, all those things are there. So if you want, you can go to the website, and once you log in, you can request for the API key. You can copy this and then paste and define the extent to download. For that you may add your base map from OSM standard and try to go to Pune region, say Pune city. Now here you will have the option of from layer, or you can use this option of use current map canvas extent. So I have selected a very small area of Pune city metropolitan region, and I will select on this use current map canvas extent. So it will create the coordinates in bounding box. Now if you see, the CRS is 3857, which are they are the coordinates of OSM map, standard map, transverse marketer. And once you give your API key, you can save the file to your system, or on the fly, if you run it, a temporary layer will be generated. So in this way you can directly download the DEM, not from one source, from different sources. Like you can get SRTM DEM, you can get Copernicus DEM, you can get ALOS DEM. These are the three very popular DEMs. So you have got the DEM for this extent as a temporary layer, and you can right click, export and save as to save onto your system. Similarly, you have another plugin for SRTM tile, downloading SRTM tiles, by the name SRTM downloader. You can also look for that. It is also popular one, SRTM downloader. It downloads SRTM tiles from NASA server, and you will require login credentials for NASA Earth data portal. There are two logins when it comes to NASA data. One is USGS Earth Explorer and another one is NASA Earth data. So once you install it, again it will create one SRTM downloader icon. You can launch it, and here you can give the bounding box latitudes and the coordinates, or you can set the canvas extent by zooming to the area. Then it will pick up the coordinates and then you click on download, and you can even check the option of load images to QGIS. For loading the images, by default the downloaded images will be saved in this folder, or you can change the path of this. And if I click on download, it will ask me for NASA Earth data login. So you can provide your username and password. So yeah, I will abort it. There are only two images, I think, which are intersecting this region. So there are, if you are taking a larger region, you can download multiple images, multiple tiles of SRTM. So these are two examples of direct download of DEM in QGIS: Open Topography DEM downloader and SRTM downloader. In the session on open access spatial datasets, we referred to Google Earth Engine as a planetary scale geospatial analysis platform, which provides you analysis ready data on the cloud, and also the computational resources will be provided by the Google data center. So all the GIS operations that you can do in QGIS on the desktop GIS for one scene at a time, you can automate, and then you can you can write a code and do the same kind of analysis for a series of images. You can make use of the data sets which are available in the Google Earth Engine data catalog on the cloud, and also the computational resources are also available. You need not have high-end configuration machine at your end. So anyway, that is a different topic, and we have a separate training program on Google Earth Engine. But there is a plugin on Google Earth Engine plugin in QGIS, using which you can access data available in the Google Earth Engine data catalog in from QGIS. And also there are minimal functionalities are made available, where you can make use of this plugin for display of data, for visualization, and for conducting small operations. You need to have a Google Earth Engine account, the account to access Google Earth Engine code editor, because this plugin will ask you for authentication of your credentials, Google Earth Engine credentials. Now let us see, we will demonstrate you how to install the plugin and where you can find the help. Like there are tutorials also available in the Google Earth Engine plugin page. So you can search for plugins, manage and install plugins, and then you type Google Earth Engine, and you will find this Google Earth Engine plugin, which integrates QGIS with Google Earth Engine by wrapping Google Earth Engine Python API. So you can install the plugin. Yeah. So at the time of installation itself, it will ask for authenticating. You authenticate Google Earth Engine. The plugin uses Google Earth Engine API, and it looks like it is not yet authenticated on this machine. Means for the first time when you are installing this plugin, you will get this message. You need to have a Google account registered for Google Earth Engine Access, which you can check by going to this URL whether you have an account, or whether if you had previously created an account, and you have to validate that you can access Earth Engine. So you can click on OK. Then it will open a new browser, new window in the browser. So it will ask you to authenticate. So you can give your credentials and then click on allow. So you can see this Google Earth Engine Authenticator will have access to your account. So you can click on allow, and it will display a message, because in this case I am using my Chrome profile wherein I have already logged in using my Google account or Gmail credentials. So in your case, maybe you may have to type in your sign in account and password. You have to input your Gmail account and password, or Google account and password. So once the credentials have been retrieved, you can close this window. So I can close this window and go back. Yes. Yeah. Now it will ask for Google Cloud Project, because since last year, uh, those who are using Google Earth Engine, earlier it was free for everyone, but they started charging for commercial use, and non-commercial use they are still giving it for free, but they have made it compulsory to register for a cloud project. Whether you have access to the cloud project or not, if you are a regular user of Google Earth Engine, you can directly log into code editor and find your cloud project name and then give the input. Otherwise, for the first time, you need to uh, register by a Google Earth Engine Google Cloud project. So you need to get the project ID. So how you can do you can get is, you can if you are a regular user, you can directly go to this Google Cloud console, and your project ID will be visible in the URL, or you can open your code editor if you are a regular user of Google Earth Engine. Yeah, this is the code editor where you type your, this is the window where you type your code and then run, and this is like a map canvas area of QGIS where the layers will be displayed, and here you will have your scripts organized in folders, docs for documentation, assets, wherein you can create your own area of interest, and vector and raster files, and which will remain private to you. And then inspector is something right side, it is similar to getting feature info like I button in the QGIS, wherein you get the pixel value or the attributes of the selected vector. Here also it performs a similar function. Then console is where you print your output tasks for whenever you are uploading any asset, or for running a long running task, this will be activated and you have to run. Now anyway, we will not get into Google Earth Engine, but if you are a user of Google Earth Engine, you can find your cloud project ID from here. You can click on project info. This is the cloud project ID. You can click on project info, and then you can copy your project ID and then paste it here and click on OK, and then you close this window. This is not required. So if you go here, yeah, and now it is installed, and you can see the plugin is installed and it is activated. Now you can close it. You can go to plugins in the main in the QGIS main menu. You go to plugins tab, and then you will find a new section of Google Earth Engine. You have a user guide, and you have these options are available. You can add image from Google Earth Engine data catalog, you can add image collection, you can add feature collection, and you can also export after calling the image, you can export it as a GeoTIFF raster file. There is a user guide. You can check the user guide. This is the web page of Google Earth Engine plugin for QGIS, where you will find a quick start guide for installation, and then using Earth Engine in QGIS, how to load satellite imagery across collections and perform geospatial analysis inside QGIS powered by Google Earth Engine. There is one section which you can have a look, and then there are tutorials on three topics: how to download images from Earth Engine, build a workflow, visualizing data from Earth Engine. These tutorials are there which you can try out. So let us check our plugins, Google Earth Engine. Say add image. First you need to have the image ID. Now in Google Earth Engine data catalog, every image, now rasters are analogous to image. Raster, if it is a single raster like DEM, it is an image. Suppose if it is a series of images, like a series of raster layers, like Landsat, Sentinel, which it is not a single image. Every day Landsat and Landsat 8 and Landsat 9 and Sentinel 2, Sentinel 1, these are acquiring imagery, and every location is revisited by these Earth remote sensing satellites, Earth observation or remote sensing satellites, after a time gap. Say in case of Landsat 8 and 9, it is 16 days. In case of Sentinel 2, it is we have 10 days, but I think effectively there are, because two satellites, it is 5 days. So it will be an image collection. So images means raster in our the general understanding that we have by doing this course on Introduction to GIS and RS and GIS. Similarly, vectors in here, vector is nothing but geometry plus some attribute information, right? So in case of Google Earth Engine, it is known as a feature. A single vector is a single feature, and then if it is a collection of features, like if it is a map of polygons of India's states, where there is no one single state but a collection, multi-polygon layer, then it is known as a feature collection in case of Google Earth Engine. So here we will demonstrate how we can add a image. Say it is given an example. Let us try this example itself. So this algorithm add image, it adds a single Earth Engine image to the map using specified visualization parameters. To find the ID, you can go to the GE data catalog, Earth Engine data catalog, wherein you will find numerous data sets. Say if I search for SRTM, SRTM digital elevation version 4. This is the page of the data, and you have this ID here, ee.image. This is the constructor, and within the parenthesis you have the ID. And there is a sample data set which you can copy and run in Google Earth Engine code editor. So say if I go here and if I paste my image ID, what is this image also, what is this data also, you can read. It is actually SRTM dataset, which is a fourth version of the SRTM dataset, and the resolution, as you can see, is 90 meters. It is similar to what we had used in CGIAR website, the void field dataset. So if you want to filter by extent, again we can make use of map canvas extent. Say you can add the base map, zoom to the extent, and you can use map canvas extent. Even otherwise I will use the map canvas extent. I think it is for the Pune region only, because earlier I had opened the QGIS for this extent only. So you can see the northern, north and southern latitude and longitudes. Then visualization parameters, I will not give any visualization parameters. It is a single band image, so you leave it as it is and check this clip to extent and click on run. So you see it is trying to get the data directly from the Google Earth Engine data catalog. Let us wait, as it is the queued task. So you can close the window. Once it is generated, you can see your SRTM, because we haven't given any visualization parameters. So it appears that it appears to be in monocolor, but actually, and without any, you cannot make out any thing about change in the elevation from pixel to pixel with default visualization parameters. But you can change the visualization parameters from within QGIS. You can go to properties and then go to symbology, single band color data. Oh, the parameters are also different. You are not getting the okay. So let us try to give the parameters this time. Let me remove this layer, but you can check the values from identify features. You have the elevation value around 573 in one of the pixel. So it has the layer has the values, but it is taking too much time to fetch the data from the Earth Engine data catalog and load. We may try to reload this using visualization parameters. Let us say I will remove the layer. Again, I will go back to plugins, Google Earth Engine, add layer, add image. I will paste my ID and I will make use of I can have a web map, base map. So I will add the base map for giving a better context. This time I will add Google Road, and let me go to Pune city. Yeah. And now let me go to Google Earth Engine, add layer, add image, copy your ID, paste your ID, and then use this map canvas extent. Now the coordinates are in this projection system 3857, because the Google road map is in this projection system CRS. Yeah, here in the visualization parameters, what you can do is color ramp. Yeah, you can create a new color ramp, just like what we have done in case of styling the elevation raster. So catalog CPT city, okay, and then you can open the topography and give the elevation. So this is the color ramp that you want to give. Minimum elevation maybe say 200 or 200. Maybe I have to take the extent of Pune district. Otherwise within the city the variation will not be much. But anyway, I will say I will give the range as 200 to 1300. And you have to take the bands of elevation. There is only single band elevation. If it is a multispectral imagery, then you can select the RGB bands and give any three bands and give them red channel, blue, green channel, blue channel. Then to generate true color composite or false color composite. Let us see. Let us run and see. I don't know whether we should select these three bands or only one band, because there is only any. So algorithm failed. Cannot provide a palette when visualizing more than one band. Okay. Close. Let us run this again. Plugin, Earth Engine, add layer, add image, and then you copy, you paste this ID, use the map extent, and use the create a new color ramp, catalog CPT city, OK, topography, elevation, and then select single band and give the minimum value say 300 and maximum value 1300, and then click on run. Yeah, now it is adding the layer, it is trying to fetch the data, and once it is done, you can close this window. Click on zoom to layer. Yes, so you see you got the DEM within the given range of values. There is not much variation, but still you can find high elevation areas here. You can make use of this identify features to get the elevation information like 909. These are above 900. In yellow portion, if I click somewhere, it will be median elevation, maybe 630, and if I click in green portion, the elevation is less than 600, 562. In this way, you can add layers directly from the Google Earth Engine data catalog. Now, we have seen a lot of DEM, but in case if you want to make use of other data sets in GE data catalog, you have so many data sets. If you explore this all data sets tab, you have a variety of data sets, all the satellite imagery of Landsat, MODIS, Sentinel, and then climatic data sets, digital elevation models, other kind of socio-economic data sets. See, there is a coffee probability model, cocoa probability model, crop maps, land use land cover maps, many global data sets, climatic data set, so many things are there. So let us add one another layer. Maybe we can try adding an image collection this time. Plugins, Google Earth Engine, add layer, add image collection. Okay, they have given the example, so we will take the same example, but you cannot copy, but no issue. You can go to the collection Landsat, say you have gone to Landsat collection, Landsat 9, surface reflectance tier 1 images. You got this ID of the ID of Landsat, then filter by image. Yeah, here you can filter even by dates. So let us filter for the month of since October 1st 2025 to 31st October 2025, or till the current day, 11th November 2025. Use the map canvas extent. Compositing method, you keep mosaic. If it is a mosaic, then if it is a smaller area, it will be covered by only one single tile. If you are looking at a larger area, there will be a mosaic. Otherwise, if you click on mean, then it will create the mean value of the different pixels for this region. If it is mosaic, the latest imagery will be displayed. and you can filter by image properties. Say you want cloud cover to be less than or equal to 30%. Now these are filters which you can find in the metadata of the imagery. You can check even in the image page what are the different properties, image properties. These are all the different properties, cloud cover. And then compositing we have chosen. So we have filtered by image property. Second one we are not giving, we remove. Compositing is mosaic, and then filter dates extent we have given. And then visualization parameters, because it is RGB, you can give the band 4, which is red band in red channel, band 3, that is green band in green channel, and band 2, that is blue band in blue channel, so that you will get a true color composite. And the values of minimum and maximum, let us check in the page whether it is simple reflectance values or scaled up values. Actually these are scaled up values. So minimum is 1, maximum is 65455. So let us give this minimum value 1, 65455. Say color ramp, I think there is no need to give color ramp because we have given the RGB bands. Now let us run this. There is a value error. Start date must be earlier than or equal to the end date. Oh, we must have made some mistake. Go to plugins, add layer, add image collection. Filter by image properties, cloud cover less than or equal to 30, compositing mosaic, start day, let me take it say from August 1st to current date, and then extent, map canvas extent, and then select the bands of B4, B3, B2, minimum 1 and maximum value 65455. Yes, okay, you have taken it as 26, 25. Now if you run this, the task is queued. Let us wait. So once it is done, you can close this, uncheck, zoom to layer. Yeah, so this is the image. There is lot of cloud cover, even though we have filtered the cloudy images. Let us try to add sentinel image from say from the months of January and February, where there will be least cloud cover. And whenever you are using this plugin, Google Earth Engine plugin, if you are if there is some after lapse of some time, you may have to re-authenticate your credentials and then give your project ID again. So say go to Google Earth Engine, add layer and add image collection. Let us try to use the same example which is provided here, which is Copernicus. Make sure you don't make mistake of when you are typing, otherwise you can copy from the ID from the page in the dataset page in the data catalog. So Copernicus slash S2, that is Sentinel-2 underscore SR surface reflectance harmonized, yes. And then you can filter by image properties. Let us say even when you are giving the particular period where the cloud cover will be less, then also you can here in case of Sentinel, the image property which has cloud cover information is cloudy pixel percentage, whereas in Landsat it was cloudy cover. It should be less than or equal to say 20, and then compositing method you take the mean, so that um, you will get a relatively cloud free image. Higher reflectance means presence of cloud, lower reflectance means presence of cloud shadow. In between mean value without cloud cover, relatively, say from January 1st 2025 to 1st March 2025, 2 months data, and filter by the same extent. We are working on the same canvas, so the extent will be same, Pune, and these coordinates are EPSG 3857, the Google map coordinates. Then yeah, visualization parameters you can give B4, B3, B2, which are corresponding to red, green and blue bands, giving red, green and blue channels. These are scaled up values, so the maximum value is around 3000. We will get this value information from the again data catalog page, and then run. So it is queued task. You wait for the completion, and the layer, once it is generated, you will find it in the layers panel. Close this, right click and zoom to layer. Yeah, it is loading. So you see it is a relatively cloud free image where you have Pune city here, Kadakwasla lake, upstream Panset and Warasgaon lake. This is downstream of Pune. Uh, you could have given the bands of B5, B4, B3 to generate false color composite. Anyway, we will not go into more details of how to use this plugin. One important functionality is you can export this image in this particular extent of the image as a GeoTIFF, and you can save it directly on your system. You give the scale same as that of the original resolution, that is 10 meters. Projection, you can you can keep the GCS, then give the layer extent, and then you can choose what all bands that you want to download. And add them, and then provide the output file, browse where you want to save. And so anyway, I am not going to do that, and you can run it. So it will export Earth Engine image to GeoTIFF. This tool allows you to export an Earth Engine image already loaded into the project to a GeoTIFF format. You must specify the extent, scale, projection, bands and output file, destination path. So that, yeah, we have touched upon few of the plugins. It is not possible to cover all many plugins in this particular session. You can further explore. Lastly, we would like to introduce one plugin which is known as WA plugin, water accounting plugin, which gives direct access to one dataset known as Vapor, WAPOR. You can look for the dataset online, which is a dataset developed by FAO, Food and Agriculture Organization. Vapor stands for Water Productivity Open Access Portal. There is a one Vapor portal. Yeah, this is the Vapor portal where you will get access to the data. So it enables you to download or access the raster data sets of actual evapotranspiration, biomass productivity, and such layers which are available in as part of the Vapor dataset. And then you can compute, you can also calculate water accounting and productivity indicators, like how much is the water consumption, how much what you can assess the irrigation performance, biomass water productivity, etc. So you can explore this data set first, and then you can install this plugin. Again, it will require a login for accessing the data. So you go to manage and install plugins and search for WA plugin. So this provides access to all Vapor data and includes in the QGIS canvas as another raster layer, providing Vapor data easy access. And also the water accounting and productivity component of the plugin will help the water management, providing the opportunity of calculating water accounting indicators to the creation of maps and reports. You can download this, you can install, and once you install you will find it under the plugin toolbar, water accounting and productivity plugin, and also here under plugin you will find it here. So the Vapor you need authentication. In order to access the Vapor version 2 datasets, you should provide the API token associated to your account. In case you don't have one, you can or do not know how to get the API token, please refer the instructions at our GitHub repository. You can even have a look at this GitHub repository, how to access or generate the API token, right? And once you have it, you can load the token, you can sign in, and then from the catalog you can download the data data sets such as evapotranspiration, biomass production, total biomass production, and then under this tab of indicators calculator, there are some uh, prior defined indicators like crop water productivity, biomass water productivity, yield, total biomass production, uniformity of water consumption, etc., beneficial fraction. Beneficial in the sense in evapotranspiration, the transpiration part is beneficial, whereas evaporation from the bare soil is considered non-beneficial. So there is you have to first go through the data set and the definitions, and then you can come and make use of this. Uh, so that's all for this session. The next session will be on LULC mapping using QGIS, which also makes use of one plugin known as semi-automatic classification plugin, SCP plugin. We haven't covered that plugin in as part of this session. We will be covering it in the next session. Thank you very much.